Today's notes, we're going to look at the 30, 60, 90 triangles. It says, use the Pythagorean theorem to find the lengths of the missing side of each triangle and simplify your answer. All right, so here's the box. This is the hypotenuse. This is our C. And A and B really don't make a difference, so I'll call this guy my A and this guy my B. So A squared plus B squared is equal to C squared. X squared plus 9 is equal to 36. If I subtract 9, x squared is 27. Let's do a factor tree on 27 because I want to take the square root. Okay, so 3 goes in 9 times, and 9 is a perfect square, which is 3 times 3. You have a pair of 3's that come out, and 3 stays in. So this is going to give me 3 roots 3. Okay, so let's go back to my triangle. We know across the box is the 6. Across the 60 is 3 roots 3. Okay, so in this triangle, across the 30 was 3, across the 60 was 3 roots 3, and across the 90 was 6. So let's just keep that in mind as we work our next example. Okay, so let's see. Here's the box. This is our hypotenuse, our C value. And let's column A, and our y is equal to b. So 4 squared plus y squared is equal to 8 squared. 16 plus y squared is equal to 64. If I subtract 16, I have y squared is equal to 48, and I want to square root it. All right, so the square root of 48, let's see, 2 goes in 24, 2 goes in 12, 2 goes in 6, and 2 goes in 3 times. So we have 2 pairs of 2 that come out. So 2 times 2 make 4, and the single 3 stays in. So again, let's take a look at what we've got. We've got across the 90 is 8, across the 30 is 4, across the 60 is 4 roots 3. Do you see a pattern? So here's the rule. It says on a 30, 60, 90 triangle, and these are the degrees of the angles, 30 degree, 60 degree, and a 90 degree. The length of the hypotenuse is 2 times the length of the shorter leg. The longer leg is root 3 times the length of the shorter leg. So sometimes I set up my rule like this. Let's see, 30, 60, 90, x root 3, and 2x. Twice the length is across from the 90, and it's x times root 3 across from the 60. All right, let's take a look at some practice problems. Find the lengths of A and B. All right, so again, we have 30, 60, 90. This is x root 3, and 2x. So what do we have? We know the guy across the 30 is 11. That's my x value in this pattern. Well, that means across from the 60 would be 11 roots 3. Across from the 90 is 2 times the x value, or 22 in this case. So across from the 60 is the A in this problem, and that would be 11 roots 3. And across from the 90, twice the x value, or 22. Let's try that again with another example. 30, 60, 90, x root 3, and 2x. All right, so this time I know the guy across from the 90. So this is the situation I have this time. 2x is equal to 24. Well, if I solve for x, divide both sides by 2, and I get x is 12. This x, we're going to plug in here and here. So that means across from the 60, and I'm missing some numbers on my paper, so let me fill this in. This is my 60, this is my 30. So across from the 30 is equal to just 12. Across from the 60 would be 12 roots 3. Okay, more practice. Find the values of t and s. All right, so 30, 60, 90, x root 3, and 2x. Okay, so let's see, what do I have? I know the guy across from the 60 is 2 roots 3. So x root 3 is equal to 2 roots 3. If I want to get the x by itself, I would divide both sides by roots 3. So x is equal to, well, 2. Plug 2 in here. that's the guy across from the 30. Plug 2 in here. Well, that would be the guy across from the 90. So across from the 30, which is my S in this case, would just be 2. Across from the 90 is 2 times the x value, and in this case, it would be 4.